Alright, so we're in section 1, linear independence. So a set of vectors in Rn is linearly independent if the equation x1v1 plus x2v2 plus xpvp equals 0 has only the trivial solution. If there exists C1 through Cp, not all 0 constants, such that this linear equation equal to 0, then the set is linearly dependent. Now, if you look back up at the top for linearly independent, we can rewrite it as a matrix equation, AX equals 0, where A is the matrix with V1 through Vp as the columns. Okay, this definition of linearly independent is going to be an important definition this semester, so you want to get comfortable with using it. Okay, so let's try to determine if some sets are linearly independent. So I'm going to list the sets out and then we can talk about them. Okay, so part A, we have the vectors 2, 1, and 6, 3. Now what do you notice about these vectors? 6, 3 equals 3 times 2, 1, right? So that means that 3 times 2, 1 minus 6, 3 equals 0, 0. So I found constants, not all 0, it's a negative 1 there, such that this linear equation has a solution that's not the trivial solution. So what does that mean? The system is linearly independent. Oops. I'm sorry, linearly dependent. Alright, in general, if you have two vectors, the set is linearly dependent if one vector is a multiple of the other vector. Alright, let's look at B. Here I have 4 vectors that all live in R3. So remember, I want to ask myself, if the system represented by AX equals 0, does this system have more than the trivial solution? Well, think about the matrix AX. That matrix is going to be 3 by 4, 3 rows and 4 columns. And so that means, since there are less rows than columns, that the system is going to have more than the trivial solution here. So again, the system is linearly dependent. And that comes from Theorem 8 in the book. Okay, so Theorem 8 says that if a set contains more vectors than there are entries in each vectors, then the set is linearly dependent. Now this last set has only 3 vectors and 3 entries in each vector, so we can't apply Theorem 8. However, this last vector here is the 0 vector. Let me call this V1, V2, and V3. Now, can you come up with constants C1, C2, and C3 such that C1, V1 plus C2, V2 plus C3, V3 equals 0, where not all C1, C2, and C3 are 0? Sure. If you let 0 be C1 plus 0 V2 plus anything that's not 0, say 2, B3, then that's going to be equal to the 0 vector. So we have a non-trivial solution here. So again, this set is linearly dependent. And in general, when the 0 vector is part of your set, the set is going to be linearly dependent. Now this is Theorem 9 in the book. Okay, so all three of these cases are cases that you should be able to answer quickly. If you have two vectors, all you need to look at is whether or not one of them is a multiple of the other one. If you have any set of vectors, if you have more vectors than there are entries in the vectors, it's always going to be linearly dependent. And if your set contains the 0 vector, the set is going to be linearly dependent. Alright, what about an example where we aren't in any of those cases? So, is this set linearly independent? Well, I want to make the matrix with these vectors as columns in the matrix, and I'm looking to ask myself, does the matrix equation with this matrix equal to 0, so the homogeneous equation, does this have more than the trivial solution? Well, from here I shouldn't actually need to do any more work. What do you notice about this matrix? It's an upper triangular matrix, and it has a pivot position in every row, right? Each of these are pivots. What does that mean? When I go to solve the system, my variables x1, x2, and x3 are all basic. So that means that there's a fixed value for each of them, and you can see when I solve here, it's going to tell me that from this bottom row that x3 equals 0. If I move up to this row, it says x2 plus 3x3 equals 0, but x3 is 0, so x2 is 0. And if I move up to the top row, again, because x3 and x2 are 0, I get that x1 is 0. So the only solution is the trivial solution. So what does that mean? It means that the set is linearly independent. Alright, so you should work on determining whether sets of vectors are linearly dependent or linearly independent by thinking of it in terms of this matrix equation. Does this homogeneous equation have more than just the trivial solution?